this video will cover section 5.1, antiderivative. And let me know if you guys have a question, but we've been covering kind of like the basics of this, right? You already know there's a word for it, they call it integral, and it's like if it was the inverse operation of taking a derivative, so that's why it's called antiderivative. So, you know probably, let's say from English, you have the protagonist and then you have the antagonist, right? Yes? So then when you say the antagonist, that's like the, I guess like the negative person or character, right? So if you are gonna, if we use the prefix for anti, right? So we're doing the opposite of the derivative, right? So if we take the antiderivative, then we are going to go backwards of the derivative, like you're doing the opposite of the derivative. So then there you get the integral, all right? So that's why we say thinking backward. So let's try to do that. And so you'll know that if you take the derivative, well, let's see what we have with the definition here. So we could use f uppercase also to represent the antiderivative of that. Now here we're not specifying what letter we're using for independence, so the statement antiderivative with the x, it will still be true, all right? And of course, if we take the derivative of the integral, I'm sorry, this should be, we take the derivative of the integral, then we get the original function. So let's say that. And to solve some of the problems, I'm going to use this notation, so let's just use it now. So if I say Dx of f of x, it will just be the original function. Okay? All right, so we're going to use that notion here, and we're going to say what is the derivative of x squared. So you know it's pretty simple, 2x. You got it there, right? So then what I'm going to say is that f of x is going to be 2x. So we're going to be using that one. So the antiderivative of 2x, or similar, like if I ask what is the integral of 2x dx, or f of x in this case is going to be x squared. So when we say think backward, I will give you the answer of the derivative, and then you're going to go back, and your answer will be what we were deriving first. That will be the integral.
Just going in reverse?
Yes, reverse. Okay, so now if we say the derivative of sine x is cosine x.
Was that antiderivative of sin x?
So that would be like cosine x. So then the antiderivative of cosine x, the antiderivative of cosine x will be sine x. Or if we use integral symbol, the integral of cosine x and then dx, that will be sine x. So we're integrating with respect to x. So at some point, right now it's just for notation to get used to. There is a part of integration, a way to integrate that it's called by substitution. So then we're going to be using something like and this will be for more complex integrals. Let, I don't know, u be x squared. So then when we say du, if we derive here u, it will be 2x dx, because we're deriving with respect to x. So then if we have to substitute the x, we're going to do something like here, the 2x and the dx are multiplying each other. And that's why this way is called by substitution. Okay? So then we do a thing that we substitute the dx, oops. And so that to substitute dx, it will be something like du divided by 2x. So then that goes back into the integral, and then, but don't stress about that yet, okay? It's not, by substitution, it's not as hard as it sounds. Then I'm not going to lie to you, there's another one called by parts, and that one is just a little more complicated. But that one is in Cal 2. So, college Cal 2. I need to make sure if I have to teach by parts. Hopefully no. Hopefully we'll stop at substitution. Okay, so then, let's go ahead and go over that theorem. So the family of antiderivatives. And so in this case, you're going to see a lot, and in fact, I should start doing that already, plus C. And that's a very bad habit of mine and of a lot of people. And so what is C? And so C is going to be a constant. Okay? And why do we always have to have a constant? Well, because, for example, if I ask you, take the derivative of x squared plus 5, what would it be? 2x. All right, now someone else besides A. The derivative, okay, Kayla, of x squared minus 3, what is it?
The derivative?
Yes. 2x, right? Or if I change this to a 13, it doesn't matter, right? It's still 2x. So because of that, once we go in reverse, there could be a constant there. We don't even know, it could be a 0, the constant, but it could still be a constant. So that when you're integrating, hold on a second, it's backwards, it's a little weird. Yes, so if we integrate, we don't know if that constant was a 0, if it was positive, if it was negative. So we just use C to account for it. And this is only for the indefinite integral, which I'm going to define next, okay? So let's go back here. Go to your next slide. And so let's just go for the definition so we can use the vocabulary. So the indefinite integral is going to be one of them that has no limits here and here, no boundaries. All right? And that one is just going to have an algebraic answer. It's not going to have a numerical answer. So it's not going to have, like, for example, a number for you already have the idea that is the area under the curve, right? And if it's below the curve, it will be negative. But when we do that with the indefinite one, we're not going to have a number telling us the exact area, whether it's positive, negative, 0. We're just going to have another equation. All right? Another, actually not equation, but expression. And so sometimes that will be, for example, I can think of the easiest of all. What's the derivative of e to the x? E to the x. So if I ask you guys, what is the integral of e to the x dx? That would just be dx. Right? So that one is pretty easy.
Oh!
Nice.
Nice.
I know. I should just go to Sam's, like a bag for each one of you. But I don't know. I might give you diabetes. All right. So that will be the indefinite integral, and then what we're taking the integral of is called the integrand. Right? Just like when we're dividing, we call this the dividend. Yes, this is the divisor because that's the one performing the division. So then for the integral, whatever you take the integral of is called the integrand. Okay, and then the for now, if you notice here, it says for now dx simply means that x is an independent variable, right? But later on, it will be very like we have to be very careful with it. It's just like good notation to keep that dx or whatever your independent variable is. So let's go to the three problems and see. This is how, before we go into the formula, I'm going to show you how to figure them out, okay? So let's see. X cubed, it is. So if we take the derivative of x cubed, it will be 3x squared, correct? Yes? Okay. So because of that, then we could say that the antiderivative for this one, which we're going to use the capital letter, so capital F of x is going to be x cubed.
So like, is there a way to like
Plus z.
automatically solve?
Yes. We're going to go into the formula. And then the next one that we have here, let's see, that one is one of the trigonometric ones, and it's actually tangent inverse.
What?
Tangent inverse of x, if you take the derivative of that one, it will be 1 over 1 plus x squared. So this is one of those formulas that you need to memorize. Okay? And so if we want to get the antiderivative from this function, the integral, it will be 1 over 1. I'm sorry, that would be the tangent inverse. I'm sorry. Tangent inverse of x plus c. Okay, and then let's do that one more. So for example, we have the derivative. What is the derivative of cosine x? Negative or positive? Negative sine x, right? Now over there we have positive sine x. So then what I'm going to do is multiply both sides by -1. So this will be positive sine x, and then we will have the derivative of negative cosine x. So then to get the antiderivative of positive sine x is going to be negative cosine x plus c. All right. So let's go to the next slide so we can look at the formula. And that's the one that we call power rule for indefinite integrals. So just like we had one for taking the derivative, something like that, and then it was n x to the power n minus 1, right? Yes? Yeah. So now for integrals, we're going to add 1 to the exponent, but also instead of multiplying by that, we're going to divide, and not just by the exponent itself, but by the exponent plus 1. All right? So we're going to do a quick proof of it. So for example, it's very short. Don't start crying. Or don't get too excited. It's short. So d over dx. And then if I take, I'm going to take this expression here, okay? And we're going to take the derivative of it. So it will be x to the power p plus 1 over p plus 1 plus c. Okay? And so in this case, what I'm going to do is break them into 2. So it will be the derivative of, and I'm going to write it this way because there is a coefficient of 1 over p plus 1. Okay?
What's dx?
Oh, I'm sorry. It should be just d. I'm sorry. It should just be d. Okay, and then the x to the power p plus 1. And then I'm going to add the derivative of the constant. Now, you already know that the derivative of the constant is going to go to 0, right? So, if we use this part right here, if we use this formula, it will give us 1 over p plus 1 times the exponent here, right? So that one, we could actually put it here, or we could put it in place of the 1 inside a fraction. And then we're going to have x to the power, the same power that we have there, which is p plus 1, and then we're going to subtract 1. And then we have plus 0 that came from here. So then what happens here, those two will cancel each other because together divided they equal to 1. And so here we're going to have x to the power p plus 1 minus 1, which is just x to the power of p. So now if we have that, this is like one of those proofs that we're done and you don't really know, right? So it's like we didn't do anything about it. So if we were to integrate here, then we will get this part right here. No problem. Okay, now theorem 5.3, if we have a constant or two functions adding to each other, then there are things that we can do to make our job easier. So, for example, here, constant c, it could be factored out. Yes, like a limit. So they do share a lot of properties. We can factor that out. And then if we have two functions adding each other inside for the integrand, then we can do one integral at a time. So we could just split them into two integrals. So the integral of a sum is equivalent to the sum of two integrals. Okay, so now let's go ahead and work with this one here. So let's just write our formula. So if we have the integral of x to the power p, that's going to be, well, dx. It's going to be x, and then remember we add 1 to the exponent, and then we divide by that same exponent. Okay? Yes? And then plus here. Alright, so here we're going to break this one into, let's say, actually we could do 2. We could take the first two terms. So the integral of 3x to the 5th plus 2 minus the integral of 5 square root of x. So first, the first thing that I'm going to do is, well, I'm going to factor this 5 out. But before that, let's go ahead and, oh, and I'm missing the x, sorry. It is a bad habit. Okay, so we take the integral of here, so we're going to follow the power rule. And so it's going to be, we're going to end up adding 1 to the exponent, so it's going to be to the power 6, and then over 6. And then for this one here, for this constant, which is a 2, remember that it has like an exponent of 0. So if we follow the same formula that we have here, what would it be? Plus 2x to what power? 1. Divided by 1. And then this one here, I could think of it as in terms of x to the 1/2. So for example, let me solve it without factoring the 5 since I didn't do it from the beginning. So we will just say, oh, and that's a minus, keep that in mind. Minus 5x to the 1/2 plus 1. How many halves are there? 3 halves. And then divided by 3 halves. And we're not done, well, almost, but we still need to simplify it.
Plus C.
Oh, yes, sorry.
We have plus 2C or just
1. Yeah, because we're there, we could be talking about a small constant and a big one, and then that would be like a combination of all the other constants that came from the grid. All right, so what we can do to simplify it, of course here, you know, right away, 3 and 6, so that will be 1/2, right? So 1/2 x to the power 6. Here we're going to have plus 2x. And then here, if we were looking at it this way, you're dividing by a fraction, right? Which is the same as you multiply by the reciprocal. So then, in reality, you have here, you're going to have the 5 over 1 multiplied by the reciprocal of 3/2, which is 2/3. And so you will have negative 10 over 3 x to the 3/2. Another way to look at it, of course, you can do that. The 5 multiplies the 2, the 3 multiplies the 1. And that's it. And plus c. Keep going. All right. Now, what do you think? What do you guys think we should do to this one before we then apply the formula?
Let's put the x squared with x.
The x squared word. Factor out the x?
No, should we put the x on top and make it negative?
Well, we could factor out constants, but not the variable. But we could do some simplify a little bit.
So, can we put the x squared on top and make it negative? Or no?
For the second one, yes, it will remain negative. So what we're doing, we're gonna take 4x to the 19 and divide by x squared.
Why?
So like they just distributing the
Oh.
fraction.
So, yeah, so like the split the fraction thing, so the x squared is dividing here, but it's also
So it
dividing.
would be 4x to the 17th, right?
Yes, because you subtract the exponents.
Minus negative 5x to the negative 10th power?
Yeah. But let me see where you guys, because I don't want to lose you guys with this one.
No.
So where are you guys good with the previous one?
Yeah.
Sure. Okay. So what I've done so far is just divide by x squared, okay? However, the next one is also being divided by x squared. So we have that, and we divide by x squared. So we will get negative 5x to the power negative 10. Okay, so in this case, we'll have the integral of 4x to the power 17 minus 5x to the power negative 10.
14x to the power 18 over 18. This was out of one, no?
Well, I'm just writing it.
Oh,
I'm not doing the integral yet. So then we go ahead and have 4x to the power, we add 1 to this exponent, so that will be 18. And then we divide by 18. Then we will have minus 5x to what power? We have negative 10 plus 1, so that will be negative 9. And we divide by the same negative 9.
Where do we add by one again?
Because that is what the formula tells us.
Oh, I see.
This one right here, yeah. So remember, we're doing the antiderivative. So when we take the derivative using power rule, we subtract. We used to subtract 1, right?
Yeah.
Well, we still do, but for derivatives. So then for integral, we'll add 1.
Oh.
Okay. But another thing that is different is that we divide, like instead of multiplying by the exponent, we divide by the exponent, but after we had already added the 1. Okay, and that one, we can simplify a little bit. So the 4 is the 18, that will be
9.
thank you,
To the
x to the 18.
Will the second one be positive since there's a negative and a negative on top? Because if you were to square, you get a negative number.
Yes.
Okay.
So positive,
So like
5 over 9, x to the negative 9, and then plus c.
Yeah.
So put that down. Okay, the other one, I'm going to
I like
write it here. So the best thing to do here is to multiply, okay? And don't think that you can take the derivative of one and then multiply it by the, the integral of one and multiply by the integral of the other. What you're going to do is first distribute them, and then we'll take the integral. So I'm going to just, for the purpose of now,
Actually, it's 2x cubed minus 5x squared minus 3x.
Where you were missing one.
I'm on. I already added. I already did the simplifying for the middle.
No, it's
Is it 2x on a negative 5x? No.
I think you're
There's
missing.
no-
Oh my god, I missed the constant. I'm so sorry. I missed it.
I told you.
Then minus 5. I'm so sorry. I apologize.
Minus 5, right? Minus 5. Okay. So we have all that. And let's go ahead and take it. So the answer will be 2x to the power 4, and then we divide by 4. I'm going to erase this from here just to make more room. For the next one,
It would be
let's see, Alejandro.
5x.
Ah,
I'm
Alejandro.
sorry.
Okay, Alejandro, what is it? 5?
5x cubed over 3.
Okay, and then Eric, next one. The 2x. 2x to the power
2.
divided by 2. Okay. Now let's see if we can simplify things. Oh, I'm missing one. Sorry.
So we're going to go with the 5.
Tiffany. Remember that? I said x to the power 0, okay?
Alright.
So minus 5 x to what power? Yeah. Divided by 1. Okay. And now let's just simplify it. So we can see here 2/4 is the same as 1/2. So 1/2 x to the 4 minus 5/3. We'll just leave it like that. We like improper fractions.
Plus 3 halves x squared minus 5.
Plus,
Are you serious?
what do you mean 3 halves?
I'm sorry.
So we have 2 over 2 though. It's not a 3. So that will be a 1 x squared and then minus 5x.
Oh, you can.
The 2 was the coefficient here.
Oh,
So it was x to the 1, so it was 2, x to the power 2. So then divided by the new exponent 2. All right.
I kind of like this. It's cool.
I knew you guys would
Oh,
like
I don't like it.
Okay, now the next one, I'm going to write a little explanation of what they are, okay? So, yes. So if we were to derive tangent of x, it will give us secant squared x. So if I ask you what's the integral of secant squared x, you think backwards, then you tell me
The tangent of x plus.
tangent of x plus secant. Good. Okay, next one. Let's, this one is going to require a few more steps, okay? But don't get discouraged. You guys are doing great.
No.
Okay, so what if I ask you the following? You could be thinking like, oh, well, maybe it's something, of course, you know it's going to be around the cosine, right? Okay. So maybe you could try to ask yourself, like, what is the cosine of 3x? And so at this point, we know it's going to be, the derivative of cosine is negative sine. So it's going to be negative sine of 3x, but then we have to use chain rule and take the derivative of the angle. And so that will be positive 3. So then this one,
Counteract that.
okay, so it's a negative 3 sine of 3x, like that. And so, of course, that's not what our question is telling us, right? So what is it? What is our question? It doesn't have the negative what?
It doesn't have the negative 3, so we should multiply by negative 1/3.
Or divide by 3, which will be the same, I guess. So it's going to say we divide by 3 and we do it to both, and it gives us the same thing that it is saying. We will be multiplying by 1/3. Negative 1/3, sorry. And that is the dx of that. Now, we don't want, where just got lost. No, yes, that's what it is. So the answer is negative 1/3 cosine of 3x plus c. right, now let's do the next one, and we see secant and tangent. Do you guys remember something that has something like that? So it's actually secant.
Yeah.
So if we just say, what is the derivative? Let me write it. Yeah. What is the ddx of secant ax? It's going to be the secant of the same angle times the tangent of that same angle, but then we need to take the derivative of the angle, right? So what's the derivative of ax? Think of a as a number, so a. Now a is the coefficient, so I'm going to move it to the front. So I'm going to have a secant of ax times tangent of ax and then here we will have ddx of the secant of ax. Okay? So now we can go back and answer the question, right? Because now, well, not really. Our question has the same angles, but it doesn't have that constant in front of it, right? When I say a constant, I'm referring to this a right here.
So you just multiply by 1 over a.
So we multiply by 1 over a or divide by a, same thing. So we could say ddx of 1 over a secant of ax is equal to secant of ax times tangent of ax. So what I want you to remember from here is that if you were to have, okay, think of this, when you have chain rule and we took the derivative of, let's say here, right here, this step right here, what did we do? We took the derivative of 3x and then we multiplied, right? So then what we're going to do over here with this integration formulas, and you see, for example, with trigonometric, and you have like an angle that is not just x, an angle for which the derivative could be something else, like a constant. So then instead of multiplying like you do with derivatives and chain rule, you will divide by that constant. Okay, so that's a little trick to remember those formulas. And a lot of those trick formulas go like that. So in this case, the answer will be 1 over a secant of that same angle, ax plus c. All right, so this is like, what I'm doing here, guys, is just like the reasoning behind it, okay? But you are supposed to, and that's why you're going to have homework, so that you could practice by looking at your tables. And so the next slide, actually, it has a table. Does someone know? Okay, so this one, we're going to refer to that table as 5.1. Okay, it's from your book.
Are these all the derivatives for the...
Integrals for trigonometric, yes.
This is a life statement. No, wait.
So, and that's why I want to give you guys homework, okay? And, I mean, expect, like, a good amount.
Like,
Times 3.
not 3, what? 3?
Like 30.
30 with...
Times 3. Okay. Just like the constant, right? Just like the constant, right? Okay. All right. So, what all you gotta do is be looking at your table and checking, like, okay, they're giving me this, so then I have to answer with that. Plus C. Don't forget to put plus C, because you'll get it. Okay?
Is there like 30 questions or like 90 more questions in each one?
I don't know.
So...
No, because this is like a
But it would be like
kind of
fast
a warm
though,
up. Yeah, like you just look at the table and get it. It's not like a multi-step
I kinda like
section.
that. I kinda
Of
like
course
that.
you do. All right, so let's use. You guys are gonna use that table, okay? 5.1 to tell me the answers for this one.
Oh, wait, but there's...
So I want you to look at that table.
So it's tangents. Oh, wait, with the three, I accidentally went to the bathroom without Tori.
Right?
I went to the bathroom.
Plus C. Sorry.
Okay.
1/3.
So look at number 3 of table 5.1. Number 3. And so what it's telling us is, let's write it over here. Our question, we're going to make our A equal 3. Okay, so our question is written like this one here, right?
It would be one
So it's just something like, we make this a 3 right here, so then the answer will be a 3 here and a 3 here.
That's what I said, 1/3.
So then it will be 1/3 tangent of 3x plus c. I'm going to forget that.
So
1/3.
1/3 tangent of 3x plus c. That's it?
Okay.
So should I send
Because you know the derivative of tangent is secant squared, right? Okay. All right. Now for the next one, think of that 1/2.
Can we do the x raised to? Wait,
Go ahead and see if you guys can do it.
cosine? Must be negative.
Because you're deriving cosine. No, you're anti-deriving cosine.
Yes. So think of this. What's the derivative of sine?
Cosine.
Positive cosine, right?
Yeah.
So then, yes, when you integrate cosine, you're going to get positive sine.
When you derive, no, when you integrate sine, you get
Negative cosine. Correct. Okay, so then this is going to be looking at the first one of table 5.1. And we're going to pretend that we have a 1/2 here for A. So then here, we're going to be dividing by 1/2. So we're going to get into one of those situations where we're going to be multiplying by the reciprocal of 1/2, which is 2. So to divide by 1/2 is going to be the same as saying 2 sine of 1/2 x plus c. Okay, now let's move on to the next one. And first of all, you guys notice how the dx is like in the numerator, right? So that's okay. All I'm going to do is move it so that it's multiplying here. And that will be exactly the same. So now, because the derivative of the natural log of the absolute value of x is 1/x.
Oh, yeah, that's not
This is a formula from the deriving. So then because of that, when we integrate 1/x, it's going to be this part right here. The natural log of the absolute value of x plus c. Yeah.
Is 1/x equal to x to the negative?
Yes, but we don't use, that's like one of those special cases when we don't use the power rule.
Yeah.
And it has like its own special.
Yeah, I got 1/0.
5.2 is not equal to negative 1.
Oh.
All right, now let's look at e to the x. And I mean, when you get something with e to the x, consider yourself lucky, okay? So then you get the derivative of e to the power ax. So it will be the same, right? E to the same power, but then we have to use chain rule. So the derivative of the power times a. So then here we could say that dx of e to the ax is equivalent to a times e to the power ax. Yeah, we all agree?
Yeah.
Okay, now that does not look like our question, almost, except that it's not being divided by a, right? Okay? I mean, I'm sorry, like it doesn't have an a here as the coefficient, or as a number multiplying to the e. And so if we just divide by a on both sides, or equivalently like a, I would say, you multiply by 1 over a. So that will be ddx of e to the ax.
Also, it's the same thing.
Well, except that instead of doing what you will commonly do when you're deriving with a chain rule and multiply by a, think of the inverse of multiplication, so you divide by a. So it's going to be 1 over a e to the ax plus e. Okay, now the next one. No, it's never time to go. Let's finish this one quickly. I promise. I promise. Okay, it's very easy. It's if we consider the derivative of tangent inverse of x, it's going to be 1 over 1 plus x squared. So now what I'm going to do here is change this x for x over a. So I'm going to put x over a, okay? I'm just going to write over it so we can finish faster. And then we'll have x over a, and then the square right here. Okay? And so what that will give us is, okay, or something like 1 over a, and then that. So then it will be a over, yeah, I will rework this one with you guys. This is way too rushed. But anyway, the answer for this one, it is just 1 over a tangent inverse of the angle x over a. So the x and the a actually come from the. Okay, but we'll review that one on Wednesday. And then there's another table on your next slide, and then there are just 3 more problems. So we'll finish on Wednesday quickly.